Hi friends, I am Ramsi PR, m.tech student of IESCE College of Engineering. Here I am discussing about the topic grouting. Grouting is a ground improvement process or technique which is attained by injecting fluid-like material called grout into the subsurface soil or rock mass of the ground. Here, a specially formulated cement of stable suspensions or liquid is injected into the pores, fissures or voids of the ground. The main object of the grouting is water sealing, then strength increasing. The most commonly used grouting material is cement slurry. The cementing helps for both water sealing and strength increment of soil or rock structures simultaneously. So thus, cement slurry is the important grouting material. Cement-based grout mixes are commonly used for gravelly layers or fissure rock treatment. But the suspension grain size particles may be too big to penetrate through the sand or silty sand layers, and in that cases, we can use chemical or organic grout mixes. But in recent years, the availability of ultra-fine grout mixes has been extended the performance of hydraulic based grout for the soil treatment. Next, grout. Grout it is a mixture of water, cement and optional materials like sand, water reducing admixtures, expansion agents, pozzolans, etc. And in this mix, water cement ratio is adopted around 0.5. For avoiding segregation in the mix, fine sand can be effectively used. Moving on to the aspects of grouting. From former discussions, we understood that the principle of grouting is to introduce a substance into rock fissures or into a soil by pumping fluid like grout. But before implementing any grouting technique in the field, there are three basic functions to be realized. Then they are the following: penetration or permeation grouting, compaction or controlled displacement grouting, hydrofracture or uncontrolled displacement grouting. Penetration grouting. In this process, joints or fractures are filled in rocks or pore spaces in soil with a grout without disturbing the soil formations. In this case, the grout flows freely with minimal effect into the soil voids or rock seams. And figure 1 shows the grouting in rocks, whereas figure 2 shows the grouting in soils. Compaction grouting. In this case, the grout remains more or less intact as a mass and exerts pressure on the soil or rock. And the grout here used is specifically designed not to permeate through the soil voids or mix with the soil. In this figure, it is clear that the grout is pumped or injected through a pipe called grout pipe and injected to the bottom, and there forms a bulb-like structure called grout bulb. Hydrofracture grouting. A deliberate fracturing of ground, that is soil or rock mass, occurs using grout under high pressure greater than ground tensile strength, and in this case the grout rapidly penetrates into the fractured zone which is created when grouting pressure implemented. This hydrofracture grouting is typically used to compact and stiffen ground or to access otherwise inaccessible voids. And the figure of hydrofracture grouting is shown here. And in this figure, three different modes of grouting is separately shown. First one shows the permeation grouting, in which grout is injected from the top through the grout pipe and grout reaching bottom spread into the different directions and form a solid mass. And in second one, compaction grouting, grout is injected through the grout pipe and form a grout bulb at the bottom. And in third figure, hydrofracturing grouting. Grout is injected through the grout pipe and grout spread in the direction of fractures. Moving on to the groutability. In order to obtain a satisfactory performance of a grout, its grain size distribution should be known because it shall show the relationship between the suspended particles and the word dimensions. And best results are obtained when the pumping pressure is not allowed to grow large enough for the particles of soil to be disturbed or moved. And for preventing blowout during grouting, the grouting pressure is generally limited to about 20 kN per meter square unless grouting under heavy structures or in other situations where greater confinement exists. Quality of the grout must be sufficiently fluid to enter the soil quickly, and this movement should not be too fast. There are three factors which decide the effect of rate of injection of a grout, and they are viscosity of the grout, permeability of the soil, shear strength of the soil. Next, moving on to the grouting material, there are different types of grouting materials and some of them are listed here. Cement, concrete, cement and clay, pulverized fly ash, asphalt, chemical products, etc. are some of them. Grouting materials may be grouped under basic two conditions, that is suspension grouts and solution grouts. In suspension grouts, water in association with mixture of one or several inert materials like cement, soil, asphalt emulsion, bentonite grout forms suspension grouts, while solution grout consists of chemical products like ligno sulphite derivatives, sodium silicate, acrylic resin, etc. in the solution. Discussing about suspension grouts briefly. When grout, that is suspension, injected, the relationship between grout particle size and soil void size is to be considered very effectively. A groutability ratio has been defined as a rough guide for the suspension grout, and this criterion decides the limit for suspension grouting. Groutability ratio denoted by GR is defined as a ratio of D15 to D85, where D15 is the particle size at which 15% of soil is finer and D85 is the particle size at which 85% of the grout is finer. And for successful operation of grouting in soil, this groutability ratio should be greater than 20. We discussed that grouting can be formed by using soil, cement, etc. And discussing grouting with soil. Soil itself can be used to fill up some of the voids in coarse grained soils. The soil to be used as a grout but should be a very fine grained soils. In case of using clay grout, it exhibits low shear strength, hence can be used to reduce permeability. In case of kaolinite and elite based clays, which produce low viscosity and are preferred as filler grout. Bentonite clay is a commonly used material whose structure is such that water is readily absorbed on its surface and enables reusability to control the viscosity, strength and flow properties. Mudjacking is the main process which is attained by grouting with soil. The mudjacking is a process of raising pavement slabs or to underpin the shallow building foundations. Next, grouting with cement. This grouting is mainly suitable for cracks or voids wider than 0.2 millimeter. And this grouting is with cement, usually formed from ordinary Portland cement and water. The water cement ratio may be varied from about 0.5:1 to 5:1 depending upon the grout conditions. Rapid hardening cement, which is finer than OPC, has a quick setting time and therefore may be preferred to OPC in ground with flowing water. Supersulfated cement is used for fissured rocks. Admixtures such as bentonite can be used to keep the cement particles in suspensions. This grouting with cement is applicable in the case of seepage cutoff beneath dams and in case of groundwater control. Grouting with cement and soil. Soil is added first to this water cement grout, then the soil acts as a filler material in this mix. If cement is added to water soil grout, then cement is considered as a stabilizer. There are two conditions. And fly ash or pulverized fuel ash can be used at the place of cement, that is, can be replaced with the cement. And the last grouting with asphalt emulsion. Asphalt is a product which is obtained as a residue of oil refinery, and asphalt is processed mixed with water and emulsifying agent, and thus grout is formed. But this grouting is a slow setting grout, thus spread into larger area than the other cases. And next, moving on to the solution grouts. Solution grout has many advantages than comparing with suspension grouts. That is, it has more control on properties. While talking about solution grout, the main grouting material or main grouting technique is chemical grouting. Chemical grouts such as silicates and acrylic resins are used. This grout solidifies by chemical reaction, and solution grout or chemical grout can be used in different cases like seepage barriers, stabilization of soil around tunnels. And in case of solution grout, the principle used is injection and permeation grouting. The following detailed classification on solution grout have been given. First one is aqueous solution, which examples are silicate derivatives, ligno sulphite derivatives, acrylamides, Pheno plus resins. Second is colloidal solution, organic solution, mineral solutions are the examples of colloidal solution. And next it is non-aqueous solution. Synthetic resins, vulcanized oils, bitumens follows under this category. And the other ones are emulsions, products reacting with ground, and the combined systems. Some of the mostly commonly used solution grout are discussed briefly, and the first one it is silicate derivatives. It is also called as watercolors, and it is commonly available and relatively inexpensive aqueous solution. Here, the sodium silicate is allowed to react with carbonic acid by the two-shot system to form a salt called sodium carbonate, which is in the solid state, and acid is formed, that is silicic acid, which is in liquid state. But this silicic acid eventually breaks down as water and silicon dioxide, and this silicon dioxide remains as solid precipitates in soil. And next discussing about ligno sulphite derivatives. Lignosulfate derivatives is formed from the lignin. That is, lignin is a residual product from the wood, and this has a this has a property that viscosity increases with time, and additives control the gelation time and uniformity of this derivative. The grouts are made from lignosulfates and a hexachromium compound, that is, soluble lignosulfate is mixed with a biochromate to form a gelatinous mass, which are quite firm. And the gel formation time varies with 10 minutes to 10 hours, which is a function of biochromate concentration, but it is very highly toxic. Moving on to acrylamides. Acrylamides has mainly these properties, that is, have constant viscosity, good penetrability, effective control of gelation time, and adequate strength. This is the main important properties of acrylamides. Acrylamides can be mixed with methylene bisacrylamides to form ammonium persulfate, which is in a gel, and this gel form like the grout in this case. This acrylamide is mainly used to control the flow of water, and it is very effective in this case of grouting. But acrylamide forms should be very toxic, and it should be avoided near the potable water sources. Next, moving on to the Pheno plus resins. Here, in this case, the resorcinol and the formaldehyde combination is mixed together to form the Pheno plus resins, and it is very stronger than the acrylamides, and toxicity is medium compared to the earliest one. Here, chemical grout system is explained. That is, many of the solution grouts are termed as chemical grouts, we know, but this chemical grout is done using mainly two systems, that is, one shot system and two shot system, which is explained. In one shot system, all the chemicals are injected together after pre-mixing, and the setting time are controlled by varying the catalyst concentration according to the grout concentration, water composition, and the temperature. While telling about two-shot system, in this case, one chemical is injected followed by the injection of the second chemical, which reacts with the first to produce a gel, which subsequently hardens. And it is slower and require higher injection pressure and more closely spaced grout holes. And here is the figure showing one shot and two shot system. The upper portion shows the two shots chemical injection setup. Here C1 and C2 denotes the chemical 1 and 2, and it is injected using the injection pump I, and is injected to the soil directly. And the bottom portion shows the one shot chemical injection setup using two chemicals, that is C1 and C2 is injected to a common mixing tank, that is empty, represented by empty, and injected to the soil. And that is the difference between one shot system and two shot system. Procedure of grouting, that is grouting procedure has to be mainly considered. There are different points to be checked while moving with the grouting, that is type of soil or rock mass should be identified or not before moving with grouting, and the soil condition should be checked, and the purpose of grouting should be known. While moving with procedure, there are mainly 5 steps to be considered. First one is pre-grouting site investigation. Second, grout hole pattern. Third one it is grout characteristics. And fourth one is grouting plant and equipment. And the last, grouting or injection methods. Moving with pre-grouting site investigation. It is essential to conduct a full site investigation before commencing grouting operation so as to decide the method of grouting and the extent of grouting required in the particular selected location. The investigation should include a geological survey and an investigation drilling. And the final study reveals the extent of soil and the rock formation, zones of weakness, depth strength, etc. of the ground. Detailed explorations are carried out by using drilling boreholes and collecting samples for the laboratory test from the drilled boreholes. In addition to all these processes or steps, a field permeability test must be conducted to facilitate more precise estimation of the required pumping pressures, grouting pattern and type of grout. And next it is grout hole pattern. Based on nature of work, the number of drill holes, depth and patterns are decided. Grouting may be of shallow depth with low pressure for filling holes. That is, shallow depth grouting is used for filling holes, while deep grouting by under high pressure is to serve a particular purpose. The grout holes are generally vertical but can be sometimes inclined, but this inclination should not be greater than 15 degree. And spacing of holes should follow a particular pattern, and this spacing of holes much depends upon the viscosity of the grout. Ideally, the spacing of grout holes should follow a grid pattern such that the radius of penetration is sufficient to cause slight overlapping between the adjacent holes. Here, the grouting pattern is shown in the figure, where it is primary holes, secondary holes and series of grouted soils are shown clearly. Moving on with grout characteristics. The grout characteristic has an important role in grouting. In order to obtain the desired effects, a grout should contain certain grout characteristics. That is, it should penetrate soil sufficiently, and it should be mainly resistant to the chemical attack when in place, and the grout should be able to develop sufficient shear strength to withstand the hydraulic gradient imposed during injection and on flowing groundwater. It should be viscous or fluid while pumping and should settle after the pumping also. Maximum volume with minimum weight is the effective character of grout. Next it is grouting plants and equipments. The basic items required for a grouting plant and their functions are discussed here. First one, it is measuring tank, which is used to control the volume of grout injected. Next, it is mixture, which is used to mix the grout ingredients. Agitator is a component which is used to keep the solid particles in suspension until pumped, which is not required for chemical grouts. And next, it is pump. Pump is used to draw the grout from the agitator to deliver to the pumping line. And control fittings are there to control the injection rate and pressure so that the hole can be generally blended with water and thin grout. Pipings are connected to the grout holes, and these are the main components or basic items required in the grouting plant. And here is the layout of grouting plant, where the grout mixture, agitator, pump and standpipe also all are shown clearly with the diagram. And this figure shows the elevation and view of grout agitator. And moving on to the last step of grouting procedure, that is injection method. Successful implementation of project depends on the skill and precision of grouting process. That is, injection process or grouting process has an important role in all the grouting technique. In selecting different injection method, there are following aspects to be satisfied. So first one, it is soils or rocks of different characteristics should be treated individually. And second, it is should be possible to treat short sections of boreholes in any sequence if necessary. And third one, it is leakage around borehole should be prevented before going with injection method. While moving with injection method, there are two methods, that is individual grouting or group grouting can be preferred. Individual grouting means grouting holes individually, one by one holes are grouted, or group grouting can be selected when the spacing is very less or the grout condition is favorable for that condition. Grouting sequences. Grouting sequences is an important topic in the grouting method, and here we go with grouting sequence. There are two different grouting sequences. First one, it is grouting from bottom to top, and second one is grouting from top to bottom. Moving with grouting from bottom to top sequence. A grout hole of 50 to 75 mm diameter is drilled to full plant depth, and in rigid soils or intact rock strata, a self-expanding packer is placed directly above the lower zone and grout is pumped in. This procedure is repeated after the packer is raised and fixed to the next zone. Thus, the drill hole is grouted successively upwards. And this is the steps of grouting from bottom to the top of the grout hole. And second one is grouting from top to bottom, that is up to down condition. In this method, holes are drilled down to the seam closest to the surface and grouting is carried out. Holes are then cleaned by washing and drilling continued to the next seam. Grouting process is then effected. Subsequent washing followed by further drilling and repeated grouting are done until the entire operation is completed. Grouting is facilitated in a particular zone by fixing packers on the top and the bottom of the grouting. And there are mainly different types of grouting, and we are now discussing with some of the common and the important one. And jet grouting follows under this category. Jet grouting. Jet grouting, it is a displacing method. That is, it replaces the soil with grout injected. Here we are injecting a low viscosity liquid grout into the pore spaces of the granular soils, and this injected grout creates hardened soils to replace soil which is loose liquefiable, in the process modifying and thereby improving the soil condition. This jet grouting can be applied to soils ranging from silt to clay, and rake rocks can be treated. That is, it is applicable from different conditions. That is, silt to clay and rake rocks can be treated. Jet grouting is commonly used to underpin foundations, to seal bottom of plant excavation, and to provide support on excavations. Jet grouting method consists of lowering a grout tube into 50 to 75 mm diameter bored grout hole, and a grout tube which is specially designed with simultaneously conveys pumped water, compressed air and grout fluid. And bottom part of the grout tube is rotating, that is one with the nozzle. While discussing with jet grouting, there are three systems of jet grouting depending upon the type of nozzles used. That is single jet grouting, double jet grouting, and the third one it is triple jet grouting. And the figure shows the three systems of jet grouting. From the figure, it is clear that in the single fluid, that is in the single grouting, jet grouting method, grout only is injected, while in case of double jet grouting, both air and grout it is injected while rotating and taking up, they form the grout column there. And discussing triple fluid or triple jet grouting, here they shows that air, water is injected through one nozzle and another nozzle is also placed at the bottom. That is, this nozzle injects grout, and that is separate two nozzles are placed in the triple jet fluid grouting. Water air mixture is usually act to cut the soil. That is, water air mixture loosens the soil and cut the soil from the holes. Water will be injecting at very high pressure, and this high pressure helps in this cutting out of the soil. And this water displaces soils up to 1.25 meter depth, and as the grout comes out from the bottom nozzle and rises from bottom to top, it displaces water and soil mixture will comes out from the grout hole. And by moving this jet grouting, a large grout column is formed rather than surrounding the soil in other cases. That is, in jet grouting, a large grout column is created. and the figure explains that is, first the pipe is inserted, that is drilled to the desired depth, and in stage 2 rod is withdrawn and rotation with high pressure injection, that is water and soil is injected at this stage of, and at this third stage, by removing this grout pipe, we are formed with a completed grout column. And advantages of jet grouting. First one, it is less dependent on soil type. That is the main advantages of jet grouting than most other grouting methods. And jet grouting can be accomplished on limited spaces, and it provides unique design flexibility, can be accomplished without causing an enormous ground disturbance, can be used to stabilize soil foundation, and jet grouting provide a barrier, and jet grouting follows a rapid installation method. That is the main advantage of jet grouting. And moving with compaction grouting. In this grouting technique, we are injecting a thick consistency soil cement grout under high pressure into the soil, which consolidate and thereby densify the surrounding soils. The injected grout occupies void space created by the pressure densification, and the figure shows that here the grout is shown. And this compaction grouting produces compaction by displacing the soil at depth until resisted by the weight of overlying soil. And this compaction grouting is done in partially saturated soils. Mixture of Portland cement and clay silty sand is mainly used as the grout for compaction grouting, in which clay adds cohesion to the grout and sand gives the high internal friction for the grout. In this method of compaction grouting, hole is drilled first, which follows bottom to top sequence, and there are different injection points throughout the length of the grout. That is the main differences from the other grouting method. And at a time of grouting is done for 2 meter, and after setting this, it is lifted to the next height. The grout holes can be vertical or inclined in case of the compaction grouting, and in case of shallow depth, closely placed injection points are used, while in case of deeper depth, far away injection points are selected. The amount of grouting is fixed by the resistance shown when the pressure is applied, and this resistance result in the lifting up of the soil and forms a heap formation. The depth of grouting in this case of compaction grouting, for lightly loaded structure, it varies from 1.8 to 3 meter, and for heavily loaded structure, this grouting depth varies from 3.2 to 6 meter. Discussing about the advantages and disadvantages of compaction grouting. Moving with advantages. Compaction grouting has a minimum disturbance to the surrounding soil or structures than compared to the other types of grouting method, and the speed of installation is very high, and waste disposal generation is absent in this case of grouting, and it is very effective in wide variety of soil condition, And compaction grouting is mainly applicable in the case of settlement remediation, that is foundation settlement or soil settlement can be easily eliminated by using compaction grouting. Moving on to the disadvantages of compaction grouting, it is very ineffective in stabilizing near ground surface due to the heap formation, that is heap is formed in the case of compaction grouting, and it is not suitable in decombustible ground or saturated clay, and excessive destabilization is very costly in the case of compaction grouting. And moving on to the pressure injector lime. This type of grouting is a special form of grouting used by lime slurry at a high pressure. Here it is injected, then the injections are spaced at 1 to 2 meter, are made at vertical intervals to maximum depth of 3 meter. And this type of grouting is suited for expensive soils with cracks, fissures, root holes, etc. Stabilizations can be achieved through reaction of lime, and then here the stabilization is achieved by the reaction between the lime and the soil adjacent to the crack, and it is very low cost method compared to the other type of method of grouting. And next it is electrokinetic injection. It is also another type of injection method or grouting method which is used in stabilizing the silty soils. And that is, silty soils are not confined itself, and this creates very difficult condition to form grouting holes, and thus chemical stabilizers are used in the case of electrokinetic injection grouting. That is, chemical stabilizers are introduced at the anode and carried towards a cathode by electroosmosis process, and DC, that is direct current electrical gradients of the order 50 to 100 volts per meter is required for this grouting, and it is very expensive method. And moving on to the last topic, that is applications of grouting. Earlier we discussed different types of grouting and methods, aspects and all other, and here we are discussing different applications of grouting. That is, grouting can be effectively used for different situations. That is, first one, it is seepage control, and that is, grouting provides a vertical seepage barriers beneath hydraulic structures and provide a stoppage of seepage through joints of underground structures such as tunnel lining or basement wall, etc. That is the seepage control explanation. And next it is vibration control. To control the vibration also, grouting is very effective. That is, for this method chemical grouting is used. That is, chemical grout alters the elastic properties of the soil and result in the increased rigidity of the base of the ground or the soil mass or rock. And another application is soil solidification and stabilization around tunnels and shafts, and foundation underpinning, restoration of verticality of a tilted building or structure, anchor systems, slab jacking are the other applications of grouting. Here the figure is shown for the slab jacking, where the grouted forms a support for the floor slab, and here different types of different applications of grouting is shown. First one shows a grout curtain below dam. And second, it is leveling structure or strengthening foundation using grout, and grouting from tunnel hudding, and grouting for subway excavation, grouting for angles, and filling of karstic caves like or holes, etc. And this is the discussing, and thank you.